Assalamualaikum and greetings to the panels. My name is Fatin ZAHRA BINTI Rosli and this is the video presentation for my bachelor's degree Viva. My project is titled Preparation, Characterization and Degradability of pectin-DES bioplastic reinforced with citric acid as crosslinker. Constant high demand of plastics around the world brings many disadvantages such as plastic waste accumulation, greenhouse gas emission and danger to aquatic species. Bioplastics enhanced with additive has been proposed as an alternative to these commercial plastics. Synthetic polymers brings more harm than benefits to the environment, but bioplastics are not favorable in the industry due to their poor mechanical characteristics. So, researchers have been enhancing them with additive while ensuring their degradability. Still, there are lack of studies regarding bioplastics enhanced with both plasticizer and crosslinker and their degradation rate. This study is in line with the 17 SDG under Goal 12 and Malaysia 12 Plan under Environmental Sustainability. Furthermore, this study can discover the potential of bioplastic as synthetic plastic alternative and improve the existing studies on bioplastic production and enhancement. The objectives of this study are to prepare pectin-DES bioplastics with varying citric acid concentration as crosslinker and to determine their mechanical properties and degradation activity. There are two research questions in this study, which are how does the concentration of citric acid as crosslinker affect the properties and degradability of pectin-DES bioplastics? Plastic waste, especially those generated by the packaging sector, have many disadvantages because they are non-biodegradable, which cause waste disposal problems and plastic accumulation. They also contain toxic monomers that persist in the environment. Bioplastics are polymers made up of renewable or bio-based resources. Depending on this factor, bioplastics can either be biodegradable or not. Plastics in group 3 and 4 as shown in the figure are made of natural resources, so they are biodegradable. Pectins are advantageous as biopolymer source. They can be used in edible film as food additive, for gelling applications and as a safe and green food packaging. However, their poor mechanical properties make them a challenging material to work with. Commercial plasticizers are disadvantageous because they can migrate in food and may be toxic to health. DES is a great alternative for this because they have low toxicity and are biodegradable. They can also be a universal additive due to their synergy with polymer components. As a DES, choline chloride ethylene glycol are biodegradable, non-toxic and inexpensive to produce. They are also versatile and they can improve the mechanical properties of bioplastics as any other commercial plasticizer. Commercial crosslinker are not preferable because they are expensive and may contain toxic molecules that can harm health. So citric acid, which comes from fruits, is a suitable, safe and non-toxic alternative which can improve the plastic properties of bioplastics. Although synthetic plastics can undergo biodegradation process, their properties makes them harder to degrade and takes a long time. So, biodegradable bioplastic is the best alternative in overcoming this problem. 1 to 2 moles ratio of choline chloride ethylene glycol DES was prepared by continuous heating and stirring at 80 degrees Celsius for 2 hours until a colorless liquid was obtained. 2.7 gram of 3% weight overweight citrus pectin and 0.9 ml of 1% DES were added with varying concentrations of citric acid to obtain a 90 ml bioplastic solution, which was stirred at room temperature for 2 hours. This solution was poured into 30 ml petri dish and dried at 40 degrees Celsius for 43 hours. FTIR was done and the spectra was recorded in the range of 500 to 4000 reciprocal centimeter at room temperature. The thickness of the bioplastic strips were measured 6 times throughout its length and the average thickness was calculated. Tensile test was done according to ASTM D882 with the following specifications, and the test was repeated 3 times for each bioplastic sample. The bioplastic samples were buried 6 cm under soil with the following control conditions. Each bioplastic sample was done in triplicates and retrieved every 4 hours until full degradation, and the rate of degradation was calculated using the shown formula. For statistical analysis, a value of P that is less than 0.05 is considered as statistically significant. The produced pectin-DES bioplastics have clear and translucent appearance with smooth surface, as shown in the figure. For comparison, different bioplastic samples have no differences in appearance, but samples with higher citric acid concentrations were thicker. The OH vibrations in this range become less intense with increasing citric acid concentration, while the C double bond O and CO bonds become more intense. These are the major peaks for the interaction between pectin, DES, and citric acid. Highest wave number recorded for OH stretch was for 4% modified pectin DES, while for carbonyl and CO stretch, the highest wave number were from control sample. OH vibration become less intense due to more esterification between pectin and citric acid, so there were less free OH groups. Since DES was of the same amount, its OH did not affect the absorption. There may also be an overlap of alcohol OH from ethylene glycol and carboxylic OH because carboxylic OH was supposed to be broader, but the amount of citric acid was too small to dominate. Carbonyl bond become more intense because more citric acid increased the carboxyl group to form more ester bond with hydroxyl group of pectin. CO bond is characteristic of DES and may form COH bonds, which were shown by the fourth peak in the spectra earlier. 3% citric acid modified pectin DES bioplastic had the highest average thickness, and the mean differences for all samples are statistically significant. Citric acid contributes to the total solid content of pectin-DES bioplastic, hence why they became thicker with increasing citric acid concentration. However, too high concentration of citric acid can cause hydrolysis of polymeric chain, which reduce viscosity and thickness of bioplastic. 1% citric acid modified pectin-DES bioplastic had the highest tensile stress value, while 4% citric acid modified pectin-DES bioplastic had the highest tensile strain. Both of these mean differences are statistically significant. Young's modulus, which was calculated by finding the area under the curve, showed that 4% citric acid modified pectin-DES bioplastic had the lowest value, hence most flexible and can elongate more. Citric acid helped to increase the macromolecules mobility and interstitial volume of the polymer, which decreased the intermolecular force and density of polymer network, enhancing their elongation. The modified bioplastics also have increased molecular space between their chains and decreased hydrogen bonds, improving their flexibility. 3% and 4% citric acid modified pectin-DES bioplastics take the longest to degrade, and 4% citric acid modified pectin-DES bioplastic had the lowest rate of degradation value. There was a statistically significant interaction between the concentration of citric acid used as crosslinker and the time taken for full degradation. Citric acid improves the bioplastic's moisture resistance and slows down microbial activity. The carbonyl stretching also releases free citric acid that slows down fungal action. Moreover, the carbonyl stretching also improves the bioplastic resistance to moisture absorption. Citric acid also acts as a barrier that improves the hydrophobicity of pectin-DES bioplastics. As a conclusion, higher concentration of citric acid enhanced the mechanical characteristics and lowered the degradation activity and water intake of pectin-DES bioplastics. Properties with different crosslinkers, degradation activity in different types of soil, and biodegradation activity of pectin-DES bioplastics may be studied in the future. With this, I conclude my presentation regarding my project. Thank you very much for your attention.